So this is video 11 of research methodology and IPR. So in the last videos, video 9 and 10, we had started with third module related to sampling, that is sampling design, the components to be included in sampling, sample design document, the different types of sampling we had started with, errors in sampling, and the characteristics of a good sample design program, right? So we had already started with probability sampling methods, and then we had started with the different types of sampling. So today in this video, that is video 11, we'll be covering up the rest of the module 3. So the last class we had already done with probability sampling, proportionate stratified sampling. So stratified sampling is nothing but you are going to make a strata, that is you are going to divide it into levels or divide it into different portions which are called as strata, and then you are going to do the sampling method on that, right? So in stratified random sampling, you have proportionate stratified and disproportionate stratified sampling, right? So we had covered with disproportionate stratified sampling. The number of sampling units drawn from each stratum is in proportion to the population size of that particular stratum again. So disproportionate stratified sampling is nothing but the number of sampling units drawn from each stratum is based on analytical variation and consideration, but not in proportion to the size of the population of that particular stratum. When differences in the stratum size and difference in stratum variability, disproportionate stratified sampling technique can be used. So when there are different size of the stratum being used and the variables are being used in a different proportion, then we can use this disproportionate stratified sampling method. Let us move on to the cluster sampling. The cluster sampling refers to a sampling method that has the following properties. The population is divided into n groups called clusters, that is capital N. The researcher randomly selects small n clusters to include in the sample. If the total area of interest happens to be a big one, that is a convenient way in which a sample can be taken is to divide the area into a number of smaller non-overlapping areas and then to randomly select a number of these smaller areas called as clusters, with the ultimate sample consisting of all units in these small areas or clusters. So this is your cluster sampling, right? So again here in cluster sampling, the total population is divided into a number of relatively small subdivisions which are themselves clusters of still smaller units, and then some of these clusters are randomly selected for inclusion in the overall sample. Suppose we want to estimate the proportion of machine parts in an inventory which are defective. Also assume that there are 20,000 machine parts in the inventory at a given point of time, stored in 400 cases of 50 each. Now using a cluster sampling, we would consider the 400 cases as clusters and randomly select small n cases and examine all the machine parts in each randomly selected case. So no doubt it reduces cost by concentrating surveys in selected clusters, but certainly it is less precise than random sampling. There is also not as much information in small n observations within a cluster as there happens to be in small n randomly drawn observations. Cluster sampling is used only because of the economic advantage it possesses. Estimates based on cluster samples are usually more reliable per unit cost. So that was about the cluster sampling. Now let us go into the details of the differences between both stratified sampling and cluster sampling. In stratified sampling, the stratified sampling method is a sampling method wherein a population is divided into several strata and a sample is taken from each stratum. In cluster sampling, it is a sampling method wherein the population is divided into two or more clusters, that is groups. In stratified sampling, randomly selected individuals are taken from all the strata, whereas in cluster sampling, all the individuals are taken from randomly selected clusters. In stratified sampling, it takes a longer period of time, whereas cluster sampling is time efficient. That is, it takes shorter time, less time. Stratified sampling requires a larger number of samples since the population is divided into several strata, while cluster sampling does not require large number of samples because they are not into several strata, only few. And stratified sampling can be expensive, whereas cluster sampling is very cost efficient, less expensive. Within strata, homogeneous characteristics between strata and heterogeneous characteristics between two strata. Within the strata, that is, in between two stratas, you have homogeneous characteristics, and between two different stratas, you have heterogeneous characteristics. Within clusters, you have heterogeneous characteristics, and between strata, homogeneous characteristics. Next, coming to the advantages of probability sampling. So, see, until now we read about the probability sampling. Before going to advantages, let me just cover few other types. Area sampling. See, for example, if clusters happen to be some geographic subdivisions, in that case, cluster sampling is better known as area sampling. In other words, cluster designs where the primary sampling unit represents a cluster of units based on geographical area are distinguished as area sampling. The plus and minus points of cluster sampling are also applicable to area sampling. Next, coming to multi-stage sampling. Multi-stage sampling is a further development of the principle of cluster sampling. Suppose we want to investigate the working efficiency of nationalized banks in India, and we want to take a sample of few banks for this purpose. The first stage is to select large primary sampling unit such as states in that particular country. Then we may select certain districts and interview all banks in that particular chosen district. This would represent a two-stage sampling design with the ultimate sampling units being clusters of districts, right? If instead of taking a census of all banks within the selected districts, we select certain towns and interview all banks in the chosen towns, this would represent a three-stage sampling design. If instead of taking a census of all banks within the selected towns, we randomly sample banks from each selected town, then it is a case of using a four-stage sampling plan. If at all we select randomly at all stages, we will have what is known as multi-stage random sampling design. That is, at different stages we are considering the sample of that particular strata to be collected. Ordinarily, multi-stage sampling is applied in big inquiries extending to a considerable large geographical area, for example, say the entire country. There are two advantages of this sampling design. That is, it is easier to administer than most single stage designs, mainly because of the fact that sampling frame under multi-stage sampling is developed in partial units, and a large number of units can be sampled for a given cost under multi-stage sampling because of sequential clustering, whereas this is not possible in most of the simple designs. In case the cluster sampling units do not have the same number of approximately the same number of elements, it is considered appropriate to use a random selection process where the probability of each cluster being included in the sample is proportional to the size of the cluster. For this purpose, we have to list the number of elements in each cluster irrespective of the method of ordering the cluster. Then we must sample systematically the appropriate number of elements from the cumulative totals. The actual numbers selected in this way do not refer to individual elements but indicate which clusters and how many from the cluster are to be selected by simple random sampling or by systematic sampling. The results of this type of sampling are equivalent to those of a simple random sample, and the method is less cumbersome and it is also relatively less expensive. you can show it in any kind of examples also, like take any numericals or any kind of research survey wherein you want to go for stratified sampling or cluster sampling. You can always have an example of that, right? And next, coming to sequential sampling. So the sequential sampling comes under your probability sampling again, right? So this sampling design is somewhat complex sampling design. The ultimate size of the sample under this technique is not fixed in advance, but it is determined according to mathematical decisional rules on the basis of information yielded as survey progresses. This is usually adopted in case of acceptance sampling plan in context of statistical quality control. When a particular lot is to be accepted or rejected on the basis of a single sample, it is known as single sampling. When the decision is to be taken on the basis of two samples, it is known as double sampling. Yes. And in case the decision rests on the basis of more than two samples, but the number of samples is certain and decided in advance, the sampling is known as multiple sampling. But when the number of samples is more than 2 but it is neither certain nor decided in advance, this type of system is often referred to as sequential sampling. Thus, in short, we can say that in sequential sampling, one can go on taking samples one after another as long as one decides to do so. That is in a sequence, in an order. Next, coming to non-probability sampling. So these all were probability sampling, right? We have to yet go through the advantages of probability sampling and also the disadvantages. See, when probability sampling or the types of sampling is asked, you can always go with this advantages and disadvantages of that particular sampling type, right? So coming to the advantages of probability sampling, it is unbiased. Quantification is possible in probability sampling. Less knowledge of universe is sufficient. Yes. See, even though you're not exposed to the entire universe or you don't have the information about the entire population, that's fine. You can still go with probability sampling and it does not have any biasing. And disadvantages of probability sampling are it takes time. Yes, it is costly. More resources are required to design and execute than in non-probability sampling. That's why we call it as it is much more expensive, right? Because it requires much more resources. So next is the non-probability sampling. Non-probability sampling is that sampling procedure which does not afford any basis for estimating the probability that each item in the population as of being included in the sample. So this non-probability sampling is also known by different names such as deliberate sampling, purposive sampling and judgmental sampling. So in this type of sampling, items for the sample are selected deliberately by the researcher. His choice concerning the items remains supreme. So here the researcher has full control and full rights to select the sample. This is non-probability sample. For instance, if economic conditions of people living in a state are to be studied, a few towns and villages may be purposely selected for intensive study on the principle that they can be representative of the entire. So here what happens, see, you in this example you want to know the economic conditions of people in a particular state. So for that you are not going for probability sampling, that is a few towns and villages may be purposely selected for intensive study and probably you know that particular state or town wherein you tend to get proper reply or genuine data from that particular place. So here biasing will be there because you are in person selecting, that is you have the entire choice of selecting the sample or the sampling unit, right? So you know where exactly or how exactly those people give the results, right? Coming to the convenient sampling. Attempt to obtain a sample of convenient elements. The selection of sampling units is left primarily to the interviewer. Often respondents are selected because they happen to be in the. So here the selection of sample units is left primarily to the interviewer. Often they are selected because they happen to be in the right place at the right time. And examples of convenience sampling are use of students, church groups, and members of social organizations, mall intercept interviews without qualifying the respondents, departmental stores, tear out questionnaires in a magazine, people on the street interviews, least expensive and least time consuming of all sampling techniques. So here what happens is it is least expensive, less expensive, and also very less time consuming compared to other sampling techniques. And then coming to judgmental sampling. It is a form of convenience sampling in which the population elements are selected based on the judgment of the researcher. So here again the researcher through the observation or his. So the researcher exercising judgment or expertise chooses the elements to be included in the sample because he or she believes that they are representative of the population of interest or are otherwise appropriate. Common examples of judgmental sampling includes test markets selected to determine the potential of a new product, purchase engineers selected in industrial marketing research because they are considered to be representatives of the company, expert witnesses which are used in the court. So all these can be used as judgmental sampling. Next is the quota sampling. What do they do in quota sampling? It involves the fixation of certain quotas which are to be filled by the interviewers. Again, here you have two stages. The first stage consists of developing control categories or quotas of population elements. To develop these quotas, the researcher lists relevant control characteristics and determines the distribution of these characteristics in the target population. The control characteristics might include your sex, age, race, and also the occupation and income level. In the second stage, sample elements are selected based on convenience or judgment. For example, you have so many n number of students appearing for a competitive exam, means only 1% of them based on quota. Next is snowball sampling. An initial group of respondents is selected. After being interviewed, these respondents are asked to identify others who belong to the target population of interest. Subsequent respondents are selected based on the opinion or referrals provided by the initial respondents. This process may be carried out in waves by obtaining referrals, thus leading to a snowballing effect. Examples are, if you are studying the level of customer satisfaction, you will find it increasingly difficult to find primary data sources unless a member is willing to provide you with contacts of other members, right? So this sampling method involves primary data sources nominating other potential primary data sources which can be used in the research. So the next one being errors in sampling. The different sampling errors. Error due to inappropriate selection of sample size. It can be minimized by choosing the appropriate sample size. As a sample keeps on increasing, the sample error also decreases. If a study is done amongst Maruti car owners in a city to find the average monthly expenditure on the maintenance of the car, it can be done by including all Maruti car owners. Non-sampling error occurs in some systematic way which is other than sampling. Sampling frame error. Errors in the specific list of population units from which the sample for a study is being chosen. Non-response error. The two major non-response issues in sampling improving response rates and adjusting for non-response. Non-response error arises when some of the potential respondents included in the sample do not respond, and refusals which result from the unwillingness or inability of people included in the sample to participate results in lower response rates. Attempts to lower refusal rates are because of prior notification, motivating the respondents, incentives, follow-up. Also, you have data error. So we have come to the end of this chapter of sample design, which third module, with this video 11. In our next video, video 12th, we will be starting up with the new model, that is module 4. Which again speaks about your data collection method, different data collection methods, secondary sources, primary sources, and different scaling techniques and all those. So we are done with 11th video as of now. Thank you.